So this question here says, suppose that 49% of people own dogs. If you pick two people at random, what's the probability that they both own dogs? So this is an and probability, so it's going to be probability of, you could say first person owns dog, call it D1, and second person owns dog, that's called D2. These are independent, so whether or not you have a dog has no effect on the fact that I might have a dog, okay? So when we find the probability of both things happening, we're just going to multiply the probability of each thing happening individually, which will give us our final answer. So it says 49% of people own dogs. So probably the first person owns a dog is 49% or 0.49. The probability the second person owns a dog is also 0.49. So to find the probability of both things happening at the same time, we're just going to multiply these two things together. 0.49 times 0.49. 0.2401. It says at least three places, so I guess that's good enough. 0.2401. Okay, that's pretty much it for that one. Second one says a quick quiz consists of a true-false question followed by a multiple choice question with 6 possible answers. If both questions are answered with random guesses, find the probability that both are correct. The probability of both correct. Well, let's first figure out how many ways this thing can be answered, okay? So the number of ways it can be correct over the number of ways it can be answered altogether. So there's a true-false question. There's 2 ways you can answer that, true or false. And then there's a 6 answer multiple choice. So there's 6 ways you can answer that. So the ways you can answer both of them is 2 times 6. You can do true and all these 6 answers, or you can do false and all these 6 answers. That's 12 possible answers. So there's 12 ways. Whoops. Hard around, sorry. So there's 12 possible ways to answer this test. So it says, what's the probability that you get both correct? Well, let's just say the answer to the first question is true. Let's say the answer to the second question is C. The only way you get both correct is if you say true and C. There's only one way to do that. So there's 1 out of 12 ways this can be done. So just divide 1 by 12 and plug in the percentage. 0.083. 1 decimal place. So 1 decimal place would be 0.1, I guess. Oh, as a percent. Okay. So it's 0.083. As a percent would be boom, boom. It would be 8.3%. That's what they want. Okay. And the third one you sent, the table summarizes the results of 987 pedestrian deaths that are caused by automobile accidents. If 2 different pedestrian deaths are randomly selected, find the probability that they both involve drivers that were not intoxicated. So it's the probability of not intoxicated. Well, it will be easier to figure out the probability of having a driver that was intoxicated. So how many accidents involve drivers that weren't intoxicated? That's going to be these 2 boxes. That's 56 plus 82. So of the 987, we have 56 plus 82 cases where the driver was intoxicated. So 138 out of 987. But this wants to know the probability the driver was not intoxicated. We have okay, so we have 2. So the chance, let's just do 1 for right now. Let's just do 1. Well, this is the chance the driver was intoxicated, so it's true. The chance the driver was not intoxicated, take the top, subtract it from 987. So we'll do 987 minus 138. So we get 894. So the chance that any one given individual was in an accident where the driver was not intoxicated is 849 over 987. That's for one individual. That's a chance that the driver was not intoxicated. But there's two pedestrians. Doesn't change no matter how many people were there, so we're going to do the same thing. And we're going to multiply those together. Times 849. Up by 9, give me 7.7399. It's a percent rounded one decimal place, so we'll say 0.7499, so we'll say 0.7. And that's it.